Hello, my name is Elizabeth Bennett, and this is my presentation for Physics 12-1-11, Lab 3. The purpose of this lab is to find the mass of a black hole given the mass and path of a star orbiting it. In the second part of the lab, we were tasked to find the initial velocity of a rocket so that the rocket gets close to the black hole without getting sucked in. The models in this lab were two GlowScript codes modeling the orbit of the Sun around the black hole and the path of the rocket. The fundamental physical principle utilized in this lab is Newton's second law, which states that the net force is equal to the change in momentum over the change in time. Change in momentum and net force can be broken into parallel and perpendicular components, where the parallel component is in the direction of momentum and gives the speed of an object, while the perpendicular component is orthogonal to the direction of momentum and gives information about the direction of an object. Because the only force acting on this system is gravity, net force is equal to the equation for universal gravitation. The major result of this experiment is that the mass of the black hole is found to be 9.017 times 10 to the 33 kilograms, and the initial speed of the rocket was found to be negative 3.18 times 10 to the 7th meters per second in the x direction and 2.6 times 10 to the 6th meters per second in the y direction. The initial conditions in part 1 of the experiment are that the star was r meters away from the black hole, going at a speed of s meters per second as determined by the randomly generated orbit. The initial velocity in part 2 of the experiment was unknown and found to be negative 3.8 times 10 to the 7th meters per second in the x direction and 2.6 times 10 to the 6th meters per second in the y direction. The initial position of the ship is on the planet, r meters away from the black hole. The system in part 1 is the Sun and the surroundings are the black hole. In part 2, the system is the rocket and the surroundings are the planet and the black hole. This is the code used to model part 1 of the experiment. Firstly, the gravitation constant was defined. Then the mass of the star was inputted as given in the problem statement. The time interval between taking the position of a star is delta t, which is equal to a day in seconds. Inside the while loop, the initial momentum is given by the initial velocity times the star's mass. The final momentum is given by the final velocity times the star's mass. The change in velocity is given by the final velocity minus the initial velocity, and the change in momentum is given by the final momentum minus the initial momentum. Then the net force was given as the change in momentum divided by the change in time. The parallel component of the net force is given by the change in magnitude of momentum over the change in time times the unit vector of momentum. The perpendicular component of net force is equal to the magnitude of momentum times the change in the unit vector of momentum over the change in time of net force, or net force minus the parallel component. The mass of the black hole is equal to the net force times the square distance between the black hole and the star divided by the mass of the star. This was found by rearranging the equation for universal gravitation. The mass of the black hole is given at every time point. Then the average of these is found to give the average mass, which is 9.017 times 10 to the 33 kilograms. For part 2 of the experiment, the initial velocity of the rocket ship was found by experimental error. The net force acting on the planet is given by the force of gravity of the ship on the planet and the force of gravity of the black hole on the planet. The net force on the ship is equal to the force of gravity of the black hole on the ship plus the force of gravity of the planet on the ship. These net forces were used in the velocity update formula for both the planet and the ship. This updated velocity was used in the position update formula for both the planet and ship to find the paths of the planet and ship. The results of this lab were that the mass of the black hole was found to be 9 times 10 to the 33 kilograms, and the initial velocity of the ship was found to be negative 3.18 times 10 to the 7th meters per second in the x direction and 2.6 times 10 to the 6th meters per second in the y direction. There are no sources of error because this lab was all computational with no experiment. The what does it mean question asks the difference between net force and the rate of change in momentum and their respective parallel and perpendicular components. Net force is equal to the rate of change in momentum, and their parallel and perpendicular components are given by the equation shown on the slide. The difference is that the net force is calculated based on known interactions between the system and the surroundings, which in this case is gravity, while the rate of change in momentum is found by observing the motion of the star's path over time. The what-if question asks what the initial velocity of the rocket ship would need to be to orbit the black hole. This was found experimentally to be negative 9 times 10 to the 5th meters per second in the x direction and negative 9 times 10 to the 6th meters per second in the y direction.